One of the most important concepts in probability is that of statistical independence. If two events are independent, P of B given A is equal to P of B. In other words, knowing that the latter event occurs do not affect the probability of the former event. For example, 4.22, we need to determine whether event K is independent of event F. F is the event a face card is selected, and K is the event that a king is selected. Now, the probability of selected a king, we have 4 kings and 52 cards, is 4 over 52, which can be reduced as 1 over 13. Now, the probability of K given F, the probability of selecting a king given that it's a face card, we have 4 kings and we have 12 face cards. It's 4 over 12. When we simplify it by 4, it's going to be 1 over 3, 1/3. And obviously 1/3 is different from 1/13. Therefore, P of K is different from P of K given F. These events are not independent. We've already calculated the probability of K is 1 over 13. B asks us to determine whether K is independent of H. P of K is 1 over 13. P of K given H, given that the selection is a heart. We have 1 king of heart and we have 13 hearts. Therefore, P of K is equal to P of K given H. Therefore, these two events are independent. R3 represents the role for assistant professor. We need to find the probability of R3, which would be the sum of the row 40,379 divided by the total number of faculty, 98,993. We get approximately 40.79%. Now we need to find the probability of R3 given G1. Given that the professor is a male, what's the probability of being an assistant professor? 2588, male and assistant professor, divided by 70,000, the total of the male column. Approximately 36.98%. these two events, G1 and R3, are not independent because P of R3 given G1 is not equal to P of R3. For the last question, they are asking us to find out if the event that a person is female, that's G2, is independent of the event that a person is an associate and an associate professor, that is R3. G2 and R3 are independent. P of R3 was already calculated, 40.79%. Now we need to calculate P of R3 given G2, and P of R3 given G2 will be equal to P of R3 and G2, which is 14,491. And the total for the G2 column is 28,993. The result is approximately 49.98%. Our conclusion is that G2 and R3 are not independent because P of R3 given G2 is not equal to P of R3. If A and B are independent events, then P of A and B is equal to P of A times P of B, because P of B given A is equal to P of B for independent event. This is called the special multiplication rule. In 3 plays, we need to find the probability that the ball will land green first, black second, and black third. The sample space has 38 numbers. The ball is equally likely to land on any of those 38 numbers. The probability of G1, the probability of getting a green as the first number, is 2 green over 38 numbers. The probability of getting black as the second number, how many blacks we have? We have 18 blacks. So it's 18 over 38. And the probability of getting black the third time is 18 over 38. Those events are independent events. Now, the probability of getting G1, green first, and a black second, B2, and a black third, B3, will be equal to PG1, 2 over 38, times PB2, 18 over 38, times PB3, 18 over 38. Quickly with the calculator, 2 over 38 multiplied by 18 over 38 times 18 over 38. And the answer is 0.11809. 0.11809. When we round it up, it's going to be 1.18%.